Throughout history, dreams have often been considered a window into the future, particularly within spiritual contexts. Various cultures and spiritual traditions have long believed that dreams can provide insights into future events. Ancient civilizations. In ancient Mesopotamia, the Epic of Gilgamesh records some of the oldest dream interpretations. The Sumerian king Gilgamesh had vivid nightmares that he couldn't interpret on his own and required an interpreter, signifying the deep spiritual and prophetic value placed on dreams in ancient societies. The Bible recounts numerous instances of dreams foretelling future events. For example, the story of Joseph, who interpreted Pharaoh's dreams in Egypt, predicting 7 years of plenty, followed by 7 years of famine. Native American traditions often regard dreams as messages from the spiritual world. Vision quests and dream interpretations are integral to their spiritual practices, with dreams believed to offer guidance and warnings. Famous individuals like Abraham Lincoln reportedly had precognitive dreams. Lincoln dreamt of his own assassination days before it happened, which he shared with his wife and friends, describing a scene eerily similar to what occurred. Carl Jung. The renowned psychologist Carl Jung believed in the significant power of dreams and the collective unconscious. Jung himself had precognitive dreams, which he thought were linked to deeper psychic insights. The 9/11 attacks. Numerous people reported having dreams that eerily predicted the tragic events of September 11, 2001. These dreams often involved images of planes crashing into buildings and other disaster-related scenarios. Have you ever experienced a dream that seemed to predict a future event? Do you find yourself wondering about the significance of strange or recurring dreams? These experiences might resonate more deeply than you think. This intriguing phenomenon is now supported by modern scientific research. A recent study by researchers from Rice University and the University of Michigan has shown that certain neurons in the brain not only replay past experiences, but also predict future ones during sleep. This discovery, published in the journal Nature, provides scientific validation for what many have long believed, that dreams can indeed foreshadow future experiences. New research suggests that certain dreams can indeed predict the future. The study discovered that during sleep, some neurons not only replay recent past events, but also anticipate future experiences. This research offers an unprecedented perspective on how individual neurons in the hippocampus of rats stabilize and adjust spatial representations during rest periods following their first run through a maze. Certain neurons respond to specific stimuli, and neurons in the visual cortex activate when exposed to appropriate visual stimuli. The neurons we are studying exhibit a preference for specific locations, said Cameron Dieber, Associate Professor of Anesthesiology at the University of Michigan and corresponding author of the study. Collaborating with Dieber and his Michigan Neural Circuits and Memory Laboratory, Rice University neuroscientist Caleb Kamir has been investigating how these specialized neurons create representations of the world following new experiences. Specifically, the researchers tracked sharp wave ripples, a neuronal activation pattern known to play a role in memory consolidation, recently shown to mark parts of new experiences that will be stored as memories. In this paper, we observe for the first time how these individual neurons stabilize spatial representations during rest periods, said Kamir. Sleep is crucial for memory and learning, a fact quantified by science through performance on memory tests after napping, as opposed to staying awake or even sleep deprivation. Decades ago, scientists discovered that neurons in the brains of animals allowed to explore a new environment before rest would fire in patterns replicating the animal's exploratory paths. This finding aligned with the knowledge that sleep helps solidify new experiences into stable memories, suggesting many specialized hippocampal neurons' spatial representations stabilize during sleep. However, researchers wondered if there was more to the story. We imagine that some neurons might change their representations to reflect new understanding gained upon waking. To prove this, we needed to track how individual neurons achieve spatial tuning, the process by which the brain learns to navigate new routes or environments. Researchers trained rats to run back and forth on an elevated track with liquid rewards at both ends, observing how individual hippocampal neurons spiked during this activity. By calculating the average spike rates over multiple runs, they estimated the neuron's place fields, the areas each neuron is most concerned with in the environment. The key point is that place fields are estimated through the animal's behavior, Khmer said, highlighting the challenge of assessing what happens to place fields during rest when the animal is not moving through the maze. I've been pondering how to assess neurons' preferences outside the maze, such as during sleep, Deba said. We tackled this challenge by linking the activity of each neuron to the activity of all other neurons. The study's key innovation was the development of a statistical machine learning method that uses the activity of other neurons to estimate where the animal is dreaming. They then use these dream locations to estimate each neuron's spatial tuning process within the dataset. The ability to track neuron preferences without external stimuli was a significant breakthrough for us, Deba said. Both Deba and Khmer praised Kourosh Mabudi, a postdoctoral researcher at the University of Michigan and the study's lead author, for his role in developing the tuning methods. The method confirmed that for most neurons, spatial representations formed during new environment experiences remain stable during sleep several hours after the experience. However, as the researchers predicted, this was not always the case. My favorite part of this study, and the reason I'm so excited about it, is that during sleep, neurons weren't just stabilizing memories of experiences, Khmer said. Some neurons ended up doing something else. We can see other changes occurring during sleep, and when we reintroduce the animals to the environment, we could verify that these changes reflected what the animals learned during sleep. It's as if the second exposure to the space occurred while the animals were asleep. This observation is crucial as it provides direct evidence of neural plasticity during sleep. Khmer emphasized that most plasticity research examines what happens when stimuli appear during wakefulness, not what happens when related stimuli are absent during sleep. It seems that brain plasticity or rewiring requires very quick time scales, Deba noted, pointing out the fascinating relationship between the duration of actual experiences and the actual memories. The duration of the actual experience might be seconds, minutes, hours, or days, while the actual memory duration is super compressed. If you remember something, the memory is instantaneous, Deba said, referencing French modernist writer Marcel Proust's famous literary passage in which childhood memories unfold an entire world of past experiences in a fleeting moment of attention. Over the past few decades, advancements in the design of stable, high-resolution neural probes and machine learning-powered computational capabilities have propelled neuroscience forward, and this study is a prime example. Given these advancements, Khmer believes that brain science will make significant progress in the future, though he expressed concerns about the impact of recent budget cuts on ongoing research. It's possible that if we were starting this work today, we might not be able to perform these experiments and obtain these results. We are very grateful for the opportunity we've had. By combining historical anecdotes, spiritual beliefs, and modern scientific discoveries, we gain a richer understanding of the profound connection between our dreams and the future. Whether through ancient rituals or cutting-edge research, the mysterious power of dreams continues to captivate and intrigue us.